In this video, I'm just going to do a quick overview of our project and kind of explain what's going on so that you have a physical image to tie to what you're seeing in our story and our code and everything that we've put on our Hackster page. First, I'm going to do a quick overview of the pin connections. Really, it's nothing complicated. The green wire, that's the ground. It's tied to the ground on the particle argon and the ground on the BME 280, nothing complicated there. Then the white wire, that's going to be the 5-volt power connection, which is tied to the VN on the BME 280 and the USB pin on the particle argon. The yellow and orange wires are what actually carry the data back and forth. The orange wire is connected to the SCL pin on the argon and the SCK pin on the BME 280. These two pins are responsible for the timing and keeping everything synchronized so the sensor knows when to take and send measurements. And the yellow wire is connected to the SDA pin on the argon and the SDI pin on the BME 280. These pins are responsible for actually carrying the data back and forth from the sensor to the argon. And really that's pretty much it with the wiring. Everything else is handled with the code. Once the data has been measured by the sensor, it just has to be transmitted and compared. And this is done by the code. And in simple terms, one argon would take 4 measurements, those being temperature, humidity, barometric pressure, and approximate altitude, and it would publish them. The second argon would then subscribe to the data the first argon had published. The second argon would then take the exact same measurements itself and compare those to the results at the first argon. Whichever argon the data output is closer to the desired measurements would then be sent the task of turning on the blue LED. The process is repeated every 20 minutes. That way we have a relatively accurate output as to which is more desirable while not constantly being uploading so much data to the cloud. The data from these measurements is also connected to ThingLink as shown here on the screen. Every 20 minutes when the data is measured and compared, it is also sent to be graphed. There's a page for the data from my house, just like there's a page for the data from Cesar's house, so the information can be easily understood while also being easily comparable if you want to compare the two. And as you can see here, it's very clear what's going on, so it would be a very, very nice thing to have if you ever wanted to look at what has been going on in the past day or two, any trends that were being followed at one or both locations. It just adds a little something to the project that makes it a whole lot more user-friendly if you ever want to go back and see what's been going on. The last thing I want to add here is a little quick clip showing our project working as best we can. Since our project is a slowly acting and mostly passive process, it's kind of hard to actually show it in the process of it going on. But to take the place of that while still achieving the same goal, in the video, Cesar will start with his LED on. And since his house is naturally closer to the goal we're looking for in our project, he will send a fake signal to the argon telling them that mine is warmer, which in turn will make my house more desirable, causing his LED to turn off.
Particle setup 1, LED on. Run a simulated temperature for particle 2 of 25. It should turn off LED on particle 1. LED is off, so that means the particle 2 board should be on.